Hello, you're welcome back. All right, so in this video, we are going to be looking at the application of moment of a force. Okay, so now there are basically two applications of moment of a force. We use moment to find the position of resultant of system of forces. Then we also apply moment in levers. So let's look at the position of resultant. How can we use moment to find the position of resultant? Okay. Now, of course, you know very well that once you resolve the resultant of system of forces, you will have a single force, which being the resultant. Okay. Now, that resultant should be acting in a position in that on that particular plane. Now, let's take for example, this is actually a plane. All right. Now, for you to, how do we use moment to calculate the position of resultant? We apply the formula. The moment of the resultant of the forces about a point is equal to the sum, the algebraic sum of the moment of all the forces about the same point. Now let's look at a typical example. All right. So I have just a beam having three forces acting on it downward. Okay. Now this is the position of the forces So there are three forces right here. 2 kilonewton, 2 kilonewton, 3 kilonewton, and 4 kilonewton. The length of the beam is 100 meter from this diagram, okay, and the distance from one end to the 3 kilonewton is 20 meter. So invariably, the distance of from the 3 kilonewton to the end of the beam, all the way to this point, okay, the distance of the 3 kilonewton to the end of the beam is going to be 100 minus 20, which of course is 80 meter. All right, so first of all, let's start with the magnitude of the resultant. So the resultant, of course, we have three forces acting downward. So that simply means that the resultant is going to be the sum of 3, 2 plus 3, then plus 4, which is 5 kilonewton. So the resultant of the system is 9 kilonewton, not 5. 9 kilonewton. So having gotten the resultant, now let's look at the position of the resultant. Okay. Now let me actually let's say the position of the resultant from the end, okay, of the 4 kilonewton. Okay, so let me take this as the position of the resultant. Let this be position of the resultant. Okay, from this end, from one end, okay, let me call it x. So the position of the resultant from this 4 kilonewton, which is acting at one end of the beam, is x. So the question is, how do I solve for x? So now, if I take moment of the resultant r about that end, okay, let me call this is point A, this is point B. About B, that is going to be equal to the moment of the resultant, which of course is going to be r, then multiplied by x. So it's going to be equal to the algebraic sum of the moment of all the forces about the same point. So the more the resultant is 9, then multiplied by x, that's what I'm looking for. 9 multiplied by x is equal to the moment of the forces. Now the moment of the force 2 kilonewton about B is going to be 2 times the distance, which is 100 meter. The moment of the 3 kilonewton about the same point B, all right, is 3 times the distance, which is 80 meter. But the moment of the 40 kilonewton about point B is 0. Moment of a force about the same point, all right, that is acting at the same point where the turning effect is always equal to 0. Why? Because there is no distance. Okay, so point B is 4 kilonewton is acting at point B, so it doesn't have the moment of the 4 kilonewton is equal to 0. So the moment of a force whose line of action is passing through the turning point is always equal to 0. So please take note of that. The line of action of work unit is passing through the same point through B. So invariably now, so the moment we have is 2 times 100, then of course plus 3 multiplied by 80, 3 times 80. Okay, so then invariably the position from B is going to be equal to 200, of course, 3 times 80, that is going to be 3 times 80, that should be 3,200 if I'm not mistaken. Okay, that is 3 times 80, that is 320 should, okay 240, please pardon me. So 240, so then divided by 9. Here we go, 200 plus 240, so divided by 9, so that is 48, approximately 49. So since the forces are in kilonewton, then the position, the distance is going to be 49 kilometer. Okay, I hope that is well understood. Okay, so now let's look at more question on this. Let's look at more question on the position of resultant. Then after which we now will solve question on levers. Okay, I've actually solved one question on that. Okay, I want to pick some question, please. Pardon me. Okay. Okay, let me okay, let's say a situation where you are being given the force. Example, force acting at the corners of a rectangle. Okay, like the previous example we actually looked at. Force acting at the corners. Forces, system of forces acting at the corners of a rectangle. Okay, so 4 forces. This one is acting in this direction. Okay, this one is of course from what I have here. This one is acting in this direction, which of course is 2p. Okay, this direction 3p, downward this is 4p, and in this direction this is p. Okay, so now the question goes this way. 4 forces are equal to 2p, 2p, 3p, and 4p are respectively acting along the 4 sides of square ABCD. Okay, so ABCD, taken in order. Find the magnitude and the direction. Find magnitude, direction, and position of the resultant. Okay, so invariably, okay, now this is actually a square of 4 forces equal to p, 2p, 3p, and 4p are respectively acting along the 4 sides of a square. So this is actually taken to be a square. Okay, so that simply means that if the length of one side is a, if the length of one side is a, that means all the side They are all A. Okay. So now let's look at the resultant. So to solve for the resultant, of course, we're going to have the vertical component of the forces square. So in this case, I'm having 2p minus 4p square, then plus the horizontal component, which of course is p minus 3p all square. So let's do this. So this is going to be equal to the square root of minus 2p square. That's going to give me 4p square. Here I still have minus 2p square also. So that will still give 4p square. 4p square. Okay, so everything is going to be 4 plus 4, that is 8. 8p square. So putting this together, of course, this is going to be the square root of 4 times the square root of 2. The square root of 8 is equal to the square root of 4 times the square root of 2. Then, of course, square root of p square. Square root of 4 is 2. Square root of p square is p. Then, of course, root 2. So that is the magnitude of the resultant. The direction of the resultant, theta, is the tan inverse of the vertical. Okay, vertical force is minus 2p. Minus 2p, horizontal force is also minus 2p. So the minus will cancel out. That's 2p all over 2p, which of course is the tan inverse. This is tan inverse of 1. So the direction is 45 degrees. Now apply moment to solve for the position of the resultant. Okay, let's say the position of the resultant from one of the force. Okay, let it be. Okay, this is the resultant from, let's say, point P. Let me call it X. Okay, there's a resultant. Let me call it X. So what we are going to do is that we are going to be taking moment about X. So I'll take moment about of the resultant about X. So if I take moment about of the resultant about X, I'm going to have the resultant, which of course is 2p root 2 then multiplied by X, is equal to, now as you can see, I'm going to take the moment of all these forces times the perpendicular distance about P. Okay, now 2P is not perpendicular. Okay, this is force 2P, so this is distance of 2P from the point. Okay, let me label it. This is A, B, C, D. Okay, so the distance of 2P from the point C is A. But it happened that 2P is not perpendicular to that point, okay? Because 2P was supposed to be this. So 2P is actually, the line of action of 2P is passing through point C, so the moment is 0. And of course P, the line of action of P is passing through the same point, point C, all right? The moment is also 0. But 4P is perpendicular, all right? The line of action of 4P is perpendicular to point C. So the moment of 4P is going to be 4P multiplied by the length of the square, which is A. So that is number 1. So that's going to be 4P, then multiplied by the length of the square, which I actually called A. Then 3P. 3P is also perpendicular, okay? So the line of action of 3P is perpendicular from points. If I trace 3P all the way, so the distance 3p is actually perpendicular to C. Okay, so, and of course the distance is still A. All right, so invariably the moment is going to be equal to 3p multiplied by the distance, which is A. So putting everything together, so S now is going to be equal to 4pa plus 3pa. That's going to be 7pa, then divided by 2 the square root, 2 square root of 2p. P cancels p, so we are having 7 all over 2 root 2a. So that is the position of the resultant. I hope that is well understood. Okay. Now there's another question right here. Okay. Let me see if I got a space to solve this. Okay, so that's another example. Okay, so this time around, there's a triangle. Okay, so I have a force acting in this direction. That force is 2p. Okay, one is acting in this direction. Okay, so, and that is a 4p. And one is acting in this direction, and that particular force is 3p. Okay, so now this is actually an equilateral. Yes, an equilateral triangle. So the side is said to be 100 meters. So as usual, we are being asked to find the resultant. Okay, the magnitude of the resultant and the position of the resultant. So how do we resolve this now? So we know that to find the resultant of this, we have to resolve the horizontal component. 2p is acting horizontally. Okay, but 4p is inclined at an angle, so we need to know the angle. The angle theta. And they also happen that this 3p is also acting at an angle to the horizontal. We need to know what this angle is with the horizontal. Okay, so first of all, how do you get to know? This is an equilateral triangle. The total angle of an equilateral triangle is 180 degrees. Okay, and the three angles are equal. So invariably, each angle is going to be 180 degrees divided by 3, which is 60 degrees. So this angle is 60 degrees. Okay, this angle is 60 degrees. This also 60 degrees. So alternate angle are equal. So that simply means that this angle right here is also 60 degrees. This is 60 degrees. Okay, so to have this angle right here, 60 plus 6 is 120. Okay, so that's going to be 180 minus 120, 0. That will still be 60. So invariably, the angle of the angle of this 3p force with the horizontal is still 60 degrees. Okay, so all we just need to do now is to resolve for the horizontal component first. Okay, so for the horizontal component, I have 2p, which is positive. So if I resolve 4p horizontally, it will be negative. All right, so that's going to be minus 4p, then cos 60. All right, and of course, if I resolve this 3p horizontally to be positive, plus 3p cos 60. Okay, so let's put it together. It's going to be 2p. Cos 60 is 0.5. 0.5 multiplied by 4p, that is minus this minus 2p. Okay, of course, cos 60 is 0.5 multiplied by 3p, that's 1.5p. So 2p minus 2p is 0, so the the horizontal component of the system of forces is just going to be 1.5p. So having gotten that, let's look at the vertical component. The summation of the vertical component of the system of forces is, of course, the vertical component of 3p, which is upward. Okay, that's going to be 3p sine 60. Then if I resolve 4p, it is going to be downward. So that's going to be minus 4p sine 60. Okay, so as a matter of fact, so I can go by special angle. Okay, sine 60 by special angle is going to be, that is 3. 3 sine 60 is root 3. Root 3 all over 2. Root 3 all over 2. Then of course p. So 4p. Okay, so I still have multiplied by root 3 all over 2. So that's going to be 4 root 3 all over 2, then p. So 4 divided by 2, that is 2. So I'm having root 3 root 3 all over 2, p, then minus 2 root 3. So solving the LCM of this, of course, p also. Solving the LCM is 2. Cross multiply, and this is going to be, of course, 2 root 3p, then minus 3 root 3p, please pardon me, 3 root 3p. I'm only solving this fraction. Then, of course, minus 3, this is 3 root 3p, then minus 2 root 3, 2 root 3p. So everything's going to give me, of course, 1 root 3p all over 2. That is my vertical component. So putting everything together now, the resultant is going to be equal to the square root of the horizontal component, which is 1.5. Okay, of course 1.5 is 3 over 2. Let me put it in fraction. Since this is in fraction, so I have to, let me put that in fraction. So this is going to be 3 all over 2 all square plus root 3 all over 2 all square. So let's do that. This is going to, resultant is going to be equal to root 2 square is 4. That's a common denominator. Then 3 square is 9. Then of course 3 square, root 3 square is actually 3. So if you add up this, so this is going to be 12. 12 all over 4. So everything is the square root of 3. So the resultant is square root of 3 Newton. Okay. I hope that is well understood. Now the position of the resultant. Okay, so that is the high point of this solution. The position of the resultant. So what we do is we take a position. All right, then we will actually solve the moment. So let's take this position 2p. So let the resultant, maybe the resultant can be anywhere. Let's say the resultant is acting at this point. Okay, so let's the distance of the resultant from that position be x. So the moment of the resultant about that point, okay, about that point is going to be r multiplied by x. Okay, so now I'm going to take the moment about that point. So already you know what it means. So the moment of 2p about this same point is 0 because the line of action of 2p is passing through. Now for 4p, the moment is going to be the vertical component of 4p. okay, about this point. At the same time, the moment of 3p about the same point is going to be the horizontal. Is that the horizontal component of 3p? Okay. If I resolve 3p horizontally, okay, yes, that is the horizontal component, but there's something I'm going to do, okay? So for 3p, look at what I'm going to do. First of all, I have to, this is the horizontal component of 3p. So for me to find the perpendicular distance, I have to find this, okay? I have to find this, I have to do some construction. Some construction, okay, yeah. This is a construction I will want to do. So that way, okay, this is the 3p, and this is the perpendicular distance of, this is the horizontal component of 3p, which already we've calculated. The horizontal component of 3p, which is 3p cos 60, then we'll have to find the perpendicular distance. So the perpendicular distance, okay, what's the perpendicular distance? That's going to be, of course, this is 60 degrees, right? This side is 100 meter. Okay, so now what are we going to, this is opposite, and of course this is hypotenuse. That's going to be sine 60 is equal to, okay, let me, what will I call, let me call it y, all right? It's equal to opposite y, opposite all over hypotenuse, which y all over 100. So invariably y now is going to be equal to 100 sine 60. So the perpendicular distance of the horizontal component of 3p, which is 3p cos 60, is 100 sine 60. Okay, so that's what I'm going to use. All right, so let's do that. Here we go. So r multiply by the position of r, then of course 4p multiplied by the 4p, the vertical component of 4p, which of course is 4p sine 60, multiplied by the position, okay, the perpendicular distance, which of course is 100 meter, then plus 3p. Okay, let me bring it on. R multiplied by x is equal to 4p sine 60 times 100, then plus the horizontal component of 3p, which is 3p cos 60, 3p cos 60, then multiply by that perpendicular distance we've just calculated, which is 100 sine 60. Okay, so let's do this. So 4p sine 60, of course, is root 3 all over 2, multiplied by 100. Of course, 3p cos 60 is 0.5, that is times 1 all over 2, times 100, times root 3 all over 2. Okay, so let's simplify. This is going to be 4 divided by 2, that is 2p. 2p multiplied by 100, that's going to be 200p root 3. Let's do this. 100 divided by 2, that is 50. 50 times 3, that's going to be 150. Okay. Okay, okay, what I would do is 100 divided by 2 is 50. 50 divided by 2 also is 25. Okay, 25 times 3, that is going to be 75. 75, okay, p, then of course root 3. So putting everything together, So the position that we are looking at is 275p, then root 3 meter. So that is the position of the resultant. So I hope that is well understood. All right, so that is it for this video. We are going to look at more in the next video. So see you in the next video. Thank you very much.